Welcome to Brain Vision.
In this problem, on the topic of alternating current circuits, we are given an RCL circuit and the value for the capacitance as well as the voltage. If we know the resonant frequency of the circuit as well as the power delivered to it, we want to find the values for the inductance, the resistance, as well as the power factor at a given frequency. So firstly, we know that since the values for the resonant frequency of a circuit are known along with the capacitance and generator voltage, we can then find the value of the inductance from the expression for the resonant frequency. The resistance can be found from energy considerations at resonance, and the power factor we know is given by cos phi, where phi is the phase angle. And we also know that tan phi is equal to XL minus XC over R. So for the first part of the problem, to find the inductance, we know L, the inductance, is equal to 1 over 4 pi squared times the resonant frequency squared F naught squared times C. And all of these values are known, so we can immediately find the inductance. So that's 1 over 4 pi squared into the resonant frequency 1.3 times 10 to the power 3 hertz squared times the capacitance of 5.1 times 10 to the minus 6 farads. So calculating, we get the inductance L to be 2.94 times 10 to the minus 3 Henry. So we've managed to solve part A and find the inductance. In part B, we want to find the resistance. Now we know at resonance that the frequency is equal to the resonant frequency F naught and the current is a maximum. This occurs when the reactive and capacitive reactances, the inductive and capacitive reactances are the same. So XL is equal to XC. So that means that Z must equal to R. And so the average power provided by the generator is V squared RMS over R. And so we have the resistance R is equal to V RMS squared divided by the average power, P bar. And this, again, these values are given. So that's 11 volts squared divided by the average power given to be 25 watts. And so calculating, we get the resistance R to be 4.84 ohms. And so that's the solution to part B. Lastly, we want to calculate the power factor at a given frequency of 2.31 kilohertz. So when the generator frequency is 2.31 kilohertz, the individual reactances need to be found first. So XC is 1 over 2 pi F times C. And again, we know these values, so we can substitute them in. That's 1 over 2 pi times the frequency of 2.31 times 10 to the power 3 hertz multiplied by the capacitance of 5.1 times 10 to the minus 6 farads. And so calculating, we get XC, the capacitive reactance, to be 13.5 ohms. Similarly, the inductive reactance, XL, is 2 pi F times L. And again, this is 2 pi times the frequency, 2.31 times 10 to the power 3 hertz, times the inductance L, which is 2.94 times 10 to the minus 3 Henry. And calculating, we get this reactance, XL, to be 42.7 ohms. Now from here we can find the power factor. But before we find the power factor, we need to find the phase angle. The phase angle phi is equal to arctan of XL minus XC over R. And this is the arctan of 42.7 ohms minus 13.5 ohms divided by the resistance R, which we calculated to be 4.84 ohms. This gives us the phase angle phi to be 80.6 degrees. And so therefore the power factor, which we know is the cosine of phi, is simply the cosine of 80.6 degrees, which is 0.163.